Hello everyone. In continuation with our hypothesis testing problems, the next problem is a sociologist at a large university believes that incomes earned by college graduates show much greater variability than those who did not attend college. So here we are talking about variability. Greater variability, that is for college graduates. What is that? It is income compared with who did not attend college. In order to test this hypothesis, he dispatches two research assistants to Bangalore to look at the earnings of these two populations. The first assistant takes a random sample of 21 college graduates and finds that their earnings have a sample standard deviation of rupees 17,000. The second assistant samples 25 non-graduates and obtains a sample standard deviation of rupees 7,500. Can we agree to the hypothesis of the sociologist at 0.01 level of significance? These are the things what we had captured. So it talks about variability or the variance of two different populations. So I will say the above this problem is concerned with comparison of two population variances. Let sigma 1 square equal to population variance of income of graduates, and the sigma 2 square is population variance of income of non-graduates. Okay. Now, first sample is of size 21. So I will say N1 sample size from first population that is given as 21. And that person noted the sample standard deviation of rupees 17,000. So sample standard deviation is rupees 17,000. And then the second population is of size 25. Second sample size. Sample size of second population is 25. Then, and he got the sample standard deviation of 7,500. See, S2, that is sample standard deviation of second population. This is of first population. Is given as rupees 7,000. Then level of significance alpha is given as 0.01. The sociologist's belief is, what is his belief? Income earned by college graduates show much greater variability than the earnings of those who did not attend college. Means he feels sigma 1 square is larger than sigma 2 square. Now, let us proceed. We will use, since it is two population variances problem, we will use F test and the test statistic is F cal, that is F calculated value, is S1 square by S2 square. S1 is known to be 17,000 per square. S2 is known to be 7,500. This will work out to 17,000 divided by 7,500, and then square that, you get 5.138. That is the calculated value. Now, here the null hypothesis is, alternative hypothesis is what is there in sociology's belief. So that itself do not have any equality sign. So that will become your alternative hypothesis. Sigma 1 square larger than sigma 2 square. So it becomes a right tail test. Null hypothesis will be both are, there is no significant difference between both the variances. Okay. Now, how do we infer? In case of a right-tailed test, if F cal, that is F calculated value, if it is lesser than F table value at n1 minus 1, comma, n2 minus 1 degrees of freedom, then we accept null hypothesis. So we need to now check what is the F tab value. F tab, here it is F table value at n1 minus 1. n1 minus 1 is 21 minus 1. 20 degrees of freedom. And then n2 minus 1, 25 minus 1. So it is 21 degrees of freedom. I'm sorry, 24 degrees of 20, 24 degrees of freedom at 0.01 level of significance. This we need to check from the tables. F tables. For 1% level of significance, this is 20, 24. Means numerator degrees of freedom is 20. Plus this is numerator degrees of freedom. This is denominator degrees of freedom. Numerator degrees of freedom is 20. Denominator is 24. We get 2.74. Yes, 2.7. Now we may notice F cal. I will write inference directly. since FCAL, which is 5.138, is larger than FCAL, which is 2.74, we reject H naught, which means we accept H1. H1 is our sociologist's belief, so we can believe the whatever the sociologist said. That is the solution of this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.